Hello, welcome again to Excelling with Naomi. Today's tutorial is all about performing a simple and also a multiple linear regression analysis in SPSS. So a simple regression analysis is one where we have only one independent variable in the model. And a multiple regression analysis is where we include more than one independent variables in the model. These are the two types of linear regression analysis that I'm going to explain how to perform in SPSS. Now I have my data and I am testing the effect of employee training on employee performance, and employee performance is the dependent variable, and the different types of employee training are the independent variables. So we have on-the-job training, we also have coaching, we have classroom-based training, and we also have workshops. These will be the independent variables in this tutorial. Now I am assuming that you know how to import your data from Excel worksheet into SPSS, and this is what I have now. Now we proceed, and let me explain the procedure for performing a linear regression analysis in SPSS. This is how you do it. You go to Analyze, select Regression, and then select Linear. Then our dependent variable is employee performance. So this is what we are going to put or to place in the dependent box. So select the variable employee performance, and using this arrow, place it on the dependent box. For the independent variable, in this first example, I am going to use only one independent variable, so this will be a simple linear regression analysis. I'm going to use on-the-job training. Select on-the-job training, use this arrow to place it on the independent list. Then you have an option to select the statistics that you want to be included in your results. But for this tutorial, I don't want to go into depth, so we are only going to leave it as it is. We are not going to get the beta coefficient estimates and also the model fit statistics. For the others, we are going to include them when we are going to test the assumptions of regression analysis. So we are going to click Continue. For the plots, also this one is used when you are testing, for example, the heteroscedasticity, the normality, and the like. So we are not going to draw any plots in this tutorial. For the method, leave it as it is at enter. If it is not enter, please make sure it is selected as enter. Then click OK. Now we have our outcome. We have a number of tables, but we are interested in just a few of these statistics. In the model summary table, we interpret the R squared value, and in the ANOVA table, we use the significance value, and then the coefficients table, we interpret the beta coefficients and the t-statistics significance values. So now this is how you interpret the R squared. For the R squared, we usually use it to explain how much out of the total percentage variation in the dependent variable, how much is explained by the independent variable. That is, of the independent variables explain, for example, in this case, 43.7% variation in the dependent variable. So we would say that 43.7% variation in the dependent variable, which is employee performance, is explained by the independent variable on the job training. So that is how you interpret the R squared. Now we go to the ANOVA table. We are going to check the significance value, which is, in this case, 0.00, and this value is less than 0.05. So this value tells us if the whole model, this model that we are using to predict employee performance, is it significant, or does it add any significance if we added these independent variables in this model? If we added them, and if we did not add these values. So if this value is less than 0.05, then we would say that the model is statistically significant, or it is significant. But if it was greater than, then we would say that it is not significant. Then we go to our coefficients table. I had explained how we interpret each of these coefficients, that is the beta coefficient and also the significance value, that is the p-value, in previous tutorials. But just as a recap, for the beta coefficient, I am going to interpret the unstandardized coefficient. And the beta value, this is the constant. First of all, this is the constant, and this is the beta coefficient for on the job training. And this means that a 1 unit change in on the job training would lead to a 0.548 change in employee performance, because employee performance is our dependent variable. So that means that if we increased on the job training by 1 unit, for example, 1 unit could mean 1 more session of on the job training, then it would mean that we will increase employee performance by 0.548. That is for simple linear regression. Then the p-value, we already say that it tests if this relationship between on the job training and employee performance is significant or not. If it is less than 0.05, then it means that it is statistically significant. But if it is greater than 0.05, then we would say that it is not statistically significant, and that means that we would not include the variable in the final model. Now for the multiple linear regression, the procedure is the same. Go to Analyze, select Regression, then select Linear. We already have our dependent variable, it is not changing. Then for the independent variables, we are going to include more variables. We now add the other variables, that is coaching. Select coaching, use the arrow to place it there. Then select classroom based, use the arrow. Then select workshops and use the arrow to place it there. To make it easier, if for example you had a list or a long list of independent variables, you select the first one, then hold the shift key down, and then select the last variable, and then use the arrow to place them in the independent box. That will make your work easier. Now we had already placed them, and so for the statistics we are also going to let it remain as it is. Then we click continue and then OK. The results or the outcomes are similar as we had in the simple linear regression, and so is the interpretation. Now we see that 69.7% variation in employee performance is explained by our independent variables. Now we have more than one, so it is explained by our independent variables, that is workshops, coaching, on-the-job training, and classroom-based training. So these variables would explain 69.7% variation in employee performance. Also, the ANOVA or the F statistic p-value is 0.00, which is less than 0.05. So our whole model or our model is significant. So including these variables in the model for predicting employee performance is significant. It is meaningful. For the coefficients table, as we have explained for the simple linear regression, it is the same. Check this is the constant. That would mean that this would be the value of employee performance if we do not have all these other or all these types of training. But if we included on the job training, then a 1 unit increase in on the job training would lead to a 0.241 change in employee performance, and then a 1 unit increase in coaching would lead to a 0.224 change in employee performance, and so the same is for classroom based and also for workshops. And checking the significance values, we have the significance value for on the job training is 0.02, which is less than 0.05, and for coaching is 0.05, for classroom based is 0.27, and for workshops is 0.12. So all these values are less than 0.05, and so we'll say that they are all statistically significant. So the relationship between these variables on the job training, coaching, classroom based training, and workshops and employee performance is statistically significant. Now, this is how you write your model, your final model, depending on the results that you get. For the simple regression analysis, we only included on the job training. So employee performance would be equal to the constant. This was our constant. If we check, this was the constant for the simple linear regression. It was 1.877, and the beta coefficient for on the job training was 0.548. So the model will be employee performance is equals to the constant, that is 1.877 plus 0.584 multiplied by the on the job training. For example, if we say that we did 3 more sessions of on the job training, that would mean that we multiply 0.548 by 3, then we add the constant. That would give us the value for employee performance. For the multiple regression model, it is similar to the simple regression model, only that now we have more or additional variables or additional predictor variables. Employee performance, which is abbreviated as EP, would be equal to, this is the constant, 0.548 0.587. Our constant was 0.587, and these were the coefficients for employee or for each of the types of training. So this would be our model. Employee performance would be equal to 0.587 plus 0.241, which is the beta coefficient for on the job training. So 0.241 times the value for all on the job training plus 0.24 coaching plus 0.249 classroom based plus 0.164 workshops. So for example, if we did 2 more sessions for each of these types of training, then would multiply their coefficients by 2. So you would have 0.241 multiplied by 1, 0.224 multiplied by 2. Maybe this was 5 sessions, this would be 0.249 multiplied by 5. Maybe we did 4 sessions of workshop training, that would be 0.164 multiplied by 4. Then we'll get the value for employee performance. And please note that all of these variables were statistically significant, and that is the reason we have included all of them in this final model. But if there was a variable or a type of training that we found that it was not statistically significant, that means that the p-value was greater than 0.05, then we would not have included it in this final model. Now I believe you know how to perform your linear regression analysis in SPSS. For a recap, go to analyze, then regression, linear, then place your variables in the boxes as appropriate, and then click OK. And now I believe you have found this tutorial to be helpful to you, and if so, please watch out for the next tutorials as I keep uploading them. Thank you and bye.